Welcome you all in this new video, and today video is going to be very interesting because in this video we are going to discuss and to study about the Stern-Gerlach experiment. Okay, this is the one of the best and you can say one of the important experiment in case of molecular physics, because this changes the dimension of our study. Okay, before this experiment there was no clue that okay, what's about how electron revolves and is there any electron spin concept. Okay, after studying this Stern-Gerlach experiment, okay, scientists and we came to know about it that yes, electron have angular momentum which is quantized. Quantized means that the angular momentum which a particular atom or electron is having, okay, that is because of spin and orbital motion. All these things were proved because of this Stern-Gerlach experiment, and this is one of the most experiment, okay, that we have to study. And in this video we are going to study about this. So I want to tell you that one drawback of this video is that here I didn't have added any kind of visual effect, so it will be a drawback for, but yes, after studying this Stern-Gerlach experiment in this video, your conceptual clarity will be absolutely fine, so don't worry about it. If your concept is good, you can visualize all the experiment in your mind, okay, very easily. So let's start our Stern-Gerlach experiment. Okay, it is one of important, guys, that's why I'm studying it. Okay, so what was the aim of this experiment? This experiment want to demonstrate that special orientation of angular momentum means what? If your angular momentum is there, okay, that will not be oriented in a special or in a particular direction, or that is not only a one quantity, okay, that can be quantized, means that can be separated or that can be divided, means angular momentum which a particular atom is having, okay, that is because of the components. Okay, it has components ups and down, and through this experiment we also came to know that electron also spins. Okay, so how we are going to prove that? With the help of magnetic field. Okay, and it was also to prove the electron spin or space quantization. Electron spin means what? You have studied it that electron have two spins, okay, upward spin and downward spins. So how we came to know about that? Because guys, understand, okay, an electron have an angular momentum, okay, and that angular momentum is half because of the spin and half because of the orbit motion. Okay, so because of spin there are two spins means two types of angular momentum, means what? That two angular momentum in the different direction which are because of their opposite spin. Okay, so there will be quantization of angular momentum, that we are going to prove in this video, okay, through this experiment, and so that's why it is very important. So you got it, what is the aim of this experiment? This experiment just want to prove that there is a special orientation of the angular momentum, okay, which is quantized and have two components up and down. Okay, and it also want to prove that yes, there is electron spin. Okay, so this was the aim. Let's start our experiment. Okay, so this was the experiment and this was the arrangement, guys. Understand one thing, that what is happening here, this is the, you can say, oven. Okay, and there is a particular atom, let's say it's a silver atom, and the silver atom was used in this experiment. Okay, silver atom is, and it is heated at a very high temperature and it is converted into an electron beam. Let's say it is the electron beam, okay, of which atom? This silver atom. Okay, and it is passing through the slits means, why this is slits means it want to coherent, means it wants to make all the electron beam in a streamline flow, in a very accurate, in a very focused manner. Okay, so here is the magnet, electromagnets property is that because their magnetic field can be changed, because why? We can change the current and their magnetic field will be changed. Okay, so we create a non-homogeneous magnetic field. Guys, what is the meaning of non-homogeneous? Like it is a north, it is the south. Okay, north south means what? It is the north pole, south pole of the magnet, and magnetic field moves like this. So if the magnetic strength is uniform throughout the path, that is called homogeneous, and if the magnetic field intensity, magnitude is changing, okay, during the course of you can say path, that is called non-homogeneous. And that electron beam, you can see this red line, okay, that is passing through this non-homogeneous north pole and south pole. Okay, in between these two poles there is non-homogeneous magnetic field. Okay, when that electron beam is passing through this non-homogeneous magnetic field, what is happening, guys? That electron beam is splitting. So we was expecting that okay, a whole beam will strike at point P. Okay, wait a minute, let me uh, yeah, whole what we are expecting, we was expecting that yes, electron is moving from this direction, okay, and we was expecting that this point, on point P, they will strike, okay. But what we get in the experiment when we studied in the final, that one is striking at the P1 and another is striking at the P2. It doesn't mean, guys, that they will strike at these two, P1 and P2, simultaneously, okay. It means that either they the particle are striking at P1 and either P2. So what was the reason behind it? That was explained by the Stern-Gerlach equation, okay. It is very important, guys, okay. So what you get from here, you get that the electron beam is not striking at the point where we was expecting, okay. Either it is striking at the point P1 or P2, okay. So why it is so, why the electron beam is striking or deviating from its main path, okay, that was explained in this experiment, and that's why it is very important, okay. So you can say there is oven, okay, and the substance is inside it, the substance which you want to use to create, okay. So by Maxwell distribution of the velocity of the electron, what he said, you know that electron have two spin, positive and negative spins, and half spins always, okay. Remind this, guys. So half spin is upward and negative is downward, okay. So working is this, no splitting, okay, there is no any splitting, guys. Remember this thing, because of this magnetic field, that line is splitting into the two, that spectral lines is splitting into the two parts, okay. But when there is no any magnetic field, there is no splitting. Remember this thing, okay. So let's move further. So this is the Maxwell distribution of the velocity of the electron. You already have studied this, okay, that this is the most probable state, and these are the formulas, okay. Vp is equal to under root 2 kt over m. This is the mean velocity. Actually, let me tell you something about Maxwell distribution of velocity of the electron. Not even velocity of the electron, any, you have any gas particle, majority of this Maxwell distribution of the velocity is used for the gaseous particle, okay. So here we are copying this concept, and we are saying that electrons are also in the huge number, okay. So electron will also move with the different velocity when they are approaching under the magnetic field, okay. So because of this, we will get Vp is what, most probable state, means that maximum, or you can say most of the electron have this velocity, okay, Vp, and we can calculate through this formula, that under root 2 kt over m, okay. So RMS is root mean square velocity, okay, that is this under root 3 kt over m. So because of Maxwell distribution of velocity of the electron, we came to say that yes, electron is changing its velocity because of the magnetic field, non-homogeneous magnetic field, okay. Non-homogeneous magnetic field, you have studied that BeV. What is this BeV? E is what, V is what, V is the velocity and B is the magnetic field. So through this formula you can easily calculate, yes, this is the deviation. And as we know, guys, understand one thing, we know that non-homogeneous magnetic field that we are using, non-homogeneous means in different point magnetic field intensity will be different, okay. So when magnetic field intensity is different, it means that velocity will also different. So velocity is also different, so because of which there is the change or distribution of the velocity among the electrons, okay, because of which they gave the separate, this strike at the different point, okay. So this was all about Maxwell distribution of velocity, okay. So now studied this, now derive this equation, okay. You just see how to derive it, okay. Let me change it, let's see, okay. Connection of the Maxwell distribution of the velocity with the electrons splitting, or what's this, toward the screen, okay. As you can see in the diagram, when it field is applied, that one line is splitting into the two, okay. Two traces are found on the screen, okay. Change or impact of the electron velocity with respect to the magnetic field, okay. I told you, guys, because of the magnetic field, there is magnetic field is non-homogeneous, and because of that there is change or variation in the velocity of the electron, okay. So don't be confused, and because of that change in the velocity of the electron, they strike or give the traces on the screen at the different points, as we studied that P1 and P2, okay. So now studied further. So now calculate that, guys. Understand one thing that we had did, that is like when your spectral line is passing through the magnetic field, okay, that is splitting into the two parts like this. So there is a mean, okay, we can say at the center, let's say this point P. So how much deviation is there when the splitting line is going away from the mean position? Mean position, let's say it's P, and what's the distance of P from P1 and P2? Okay, this is P2. So guys, remind one thing: if a spectral line or if a electron beam is splitting because of the magnetic field, that will be separated at the equal distance from the point where we was expecting without the magnetic field. Okay, so that was P. So now let's derive that how much distance is this. Okay, we know that, okay, yeah, that line is splitting, okay, because of the magnetic field. So what is the range of that splitting? Okay, what's the distance from the mean position? That we have to derive here, and that we will calculate. And that, because of that, we came to know that yes, electron is splitting through this much distance up and down from the mean position where we was expecting without the magnetic field. Okay, so let's start our video. Sorry, let's start this derivation. uh, let's say we will prove this thing by the quantum theory. And quantum theory, what did it say? It said that consider a silver atom that I told you that as the dipole, okay, or the bar magnet. Let me explain it a little bit. So what it's saying, it's saying that let's a silver atom as the dipole. Dipole means what, guys? Dipole would have two poles, okay, or bar magnet like this. You have to found it like north and south. You are expecting like this. Okay, so assume that silver atom is acting like a bar magnet, and when you put a bar magnet in the magnetic field, what happened, guys? Bar magnet start rotating in the field of magnetic field, okay, in the direction of magnetic field. So let's say this is what? Mu j. Mu j is what? This is the total angular momentum. Total angular momentum is because of the spin angular momentum and orbital angular momentum. Okay, so this is the mu b gj, okay, under root small j plus 1. This is what, guys? This is the value of total angular momentum. Okay, you had separately studied it. I'm just applying all the, I'm accumulating all the concept and putting on this Stern-Gerlach equation, okay, so that you can easily identify, yes, this is the concept like this. Okay, so what is this mu b? Mu b is Bohr magneton. Okay, this is E h dash over 2m. H dash value is what, guys? H dash value is h over 2 pi. Okay, so don't be confused. And so then you can, what is the gj? This is called Landy's, okay, g factor. So this is what 1 plus j plus 1. Okay, you can easily derive it. It's not that much hard to derive. So let me directly come to the concept. So this is the concept, guys. So assume that this is the north pole, this is the south pole, and here is the bar magnet that we had considered. That we considered that silver atom is similar with the bar magnet. Okay, so because it is a similar with the bar magnet, so it will rotate within the magnetic field and with the direction of magnetic field. Let's assume that, okay, the rotation of this bar magnet is with the angle theta. Okay, so when a particular thing rotate, we know that there is the torque which come into the action. Okay, torque is what? It is nothing, it is just a rotational force. Okay, so torque is equal to the mu j into b. Mu j is what? It's, you can say this is the angular momentum, or you can say it is the magnetic momentum of that particular magnetic bar, okay, or that bar magnet, or you can say silver atom. Okay, so this is the mu j over b sine theta. Theta is the angle through which it is a deviating, okay, through which it is a rotating. So when it is a rotating, so it gain, because of the change in the position, it gains some potential energy. Potential energy is what? It is because of the change in the position. Okay, potential energy is gained through the rotation, okay, is about angle theta. Okay, so this is the, you have to take the integration of this. So this will come minus mu j or b cos theta. Okay, sine theta integration is what? Cos theta. So you can easily calculate it. So this is the potential energy. Let's move further. So potential energy is this. So put the cos theta is equal to mu j into j plus 1. Mu j is what? Mu j is nothing plus j and all the terms between minus j. The terms between minus j and plus j, that is called mu j. Okay, sorry, mj. So this is cos theta value is this. Okay, put the cos theta value here, and gj value is 2. Okay, this is nothing, it's the g factor. Okay, g factor is also like for spin, you can say g factor is what? Minus 2. For angular, or sorry, for orbital motion, what is the g value? G value is 1. So you know all these things. Okay, so this is the potential energy that we got. Okay, so now potential energy is this, guys. Okay, this is the potential energy. So mj, put the mj value here. Mj value is what? Plus minus 1 over 2. It means that j value is what? 1 over 2. Okay, so this is the value of mj. Put the value of mj here, so you will get like this. So what does this mean? It means that the lines without splitting and striking at the point P1 and P2, they are at a distance from the P with the difference of plus UB, okay, mu B B. B is what? Magnetic field. Mu B is what? Bohr magneton. So this mu B B is the difference between the traces that we are founding at P1 and P2, okay, from the P point. Okay, so this is the energy at P1 and P2. Okay, so this is the energy difference. Now in the another form you can say what is the displacement. I am talking about this one displacement. Okay, what is this displacement? Let's say this is the displacement Z. Okay, if we say that this is a displacement Z, okay, we can directly start from here. What's the displacement? Displacement, you have studied this formula. Okay, this is 1 over 2 plus minus 1 over 2 AT square, because displacement is both side, guys, from P to upwards and to downwards also. So you can easily calculate from here what is the A is the acceleration. A acceleration that we know, force over mass and 1 over m. So this is the value of force. Okay, force is what? Mu B, rate of change of the magnetic field with respect to the what? With respect to the axis we are studying about it. Okay, let's say this is the x-axis, sorry, z-axis. So we are studying this thing in the z-axis, and magnetic field is also changing with the z-axis. Okay, so we will take this thing here. So you will derive this thing, and this is the expression that you will get at the end. Let me do it further. So guys, this is the experiment that you got. Okay, as per the Maxwell distribution law, I told you guys, electrons are spinning and they are giving the separate traces on the screen. Why? Because of their difference in the velocity. Difference in the velocity was studied by the Maxwell, and he gave a specialized formula for it, and we used that formula. That's why we are saying this. Okay, so we use this formula here. Okay, put the value of V, mv, put the value of V here. You will got at the final expression, that is Z is equal to plus minus 1 over 6 mu B L square KT over partial differentiation of the B magnetic field with respect to the axis with which we are considering it. Okay, this is the mu B over Z is what? This is the rate of change of the magnetic field. Okay, so this is the rate of change of the magnetic field with respect to the z-axis. So Z is what? This is the change, or this is the displacement from the mean position. Mean position was what? P. When we applied the magnetic field, so this much is the displacement. This much is the intensity of the displacement through which the particle will displace, okay, from the mean position. So this was the contribution of the Stern-Gerlach experiment, you can say. Okay, so this was spin orientation. So this was all about, guys, Stern-Gerlach experiment. What he proved? He proved that electron spin is there, and also angular momentum, okay, you can say is quantized in nature. Means what? The angular momentum that we consider for any particular atom or electron, that is the combination of the spin angular momentum or orbital angular momentum. Okay, as we studied it. Why? When we are saying that electron is splitting into the two parts, it means that one is upward and one is downward, means there are different spin. If there is different spin, their angular momentum will be different. You can say if we have to combine these things, okay, if we have to calculate the whole momentum, okay, whole angular momentum, so we will combine these. Means angular momentum is not a single quantity, okay, it is the combination of the various component. Okay, so that's all about Stern-Gerlach experiment. And thank you so much. If you like our initiative, then give a thumbs up and do subscribe our channel.